Hi everyone, this is Mrs. G, and today we're going to be modeling with quadratic functions. But first, I have a quick warm-up for you guys, so please give it a try. All right, go ahead and check your work here. For the first one, you can see that we're pretty close to vertex form, but you need to do a little extra work to simplify before you determine the vertex, which should be at +3, -5. For the second example, we're in intercept form. So remember, your vertex will always lie exactly halfway between your intercepts. So that will occur when x equals 3/2, and then plug that back in to find the y value. You should have simplified fractions as the directions stated. And for this last one, we need to use this formula. It is in standard form, so we can use -b/2a to help us find the x value of our vertex, and then just plug it back in to find the y value. So this was just kind of a quick overview of how we use the different forms of quadratic equations, which we will also be using today. All right, so today we're going to be writing quadratic functions that we can use to model a graph or a set of data. So depending on what information we're given, we would use a different strategy to create that model. So if we are given a point and the vertex, so the vertex and any additional point on our graph, for this we will want to use vertex form. And then we substitute that additional point to help us find that a value, which we'll need to complete our function. But if we are given the vertex, we will want to use vertex form to help us. We do need that additional point though. Now, if we are given the x-intercepts an additional point, we are going to want to use that intercept form. And then we will use that additional point again to help us complete our quadratic model. But again, we will need that additional point so we have the full model. And then maybe we don't have the intercepts, we don't have the vertex specifically, but if you have at least 3 points, we can create a quadratic model using standard form. And we could actually create a system of equations to help us solve for A, B, and C. But from standard form, since there are 3 variables, A, B, and C, we do need those 3 points, so we have 3 equations to help us. We're also going to look at how our graphing calculator can help us create this quadratic model as well. All right, so let's look at this first example together. Here we have a graph that shows the parabolic path of a performer who is shot out of a cannon. So notice that the y-axis represents the height of that performer in feet, and the x-axis represents the horizontal distance traveled in feet. It is important that we note what our axes represent. Sometimes the x-axis represents a horizontal distance, but it's also very common for it to represent a unit of time. So just make sure you understand what your graph really represents. Then this says the performer lands in a net 90 feet from the cannon. What is the height of the net? So we want to know the height when x equals 90. So I'm going to put a little note there, when x equals 90. So to help us do this, we're going to need to first create a model of this path so then we can use the model to answer this question. So that's one reason why we create models, to help us answer questions about our data or whatever scenario we're working with. So for this one, you'll note that we have the vertex, which we can see in the graph is 50, 35, and we have an additional point. In this case, it's that y-intercept, but any additional point will work. So you'll note here, when x is 90, this point we don't know. We can't just estimate it. I mean, we have an idea of what that y value is, but to get an exact answer, we need to create the model. So remember, if you are given the vertex an additional point, we are going to use that vertex form to help us model. So we can start by substituting our vertex, so x minus 50 squared plus 35. But you'll see that we still have this a value that we need to solve for, which is how we're going to use that additional point. So we're going to substitute our x and our y with 0 and 15 respectively to help us solve for a. So then we have 0 minus 50 squared plus 35. And then 2,500. And then we can use our calculator to help us get a decimal approximation for this. We get A equals negative 0.008. So that's our A value. So now we have everything we need to make our model. So let's say f of x equals negative 0.008 times x minus 50 squared plus 35. And now we can answer our question. They're asking when x equals 90, which is that horizontal distance, what is the height? So we can just simply do f of 90. So we substitute 90 for x. And then we can let our calculator do the rest. And we should get 22.2. So that means if it asks what is the height of the net, we would say 22.2 feet. We'll just make sure to include the proper units for our final answer. So again, it was important for us to be able to create this model of this quadratic function so we could then answer this question about a y value given an x value. All right, let's do another one together. So a meteorologist creates a parabola, which is shown here in this graph, to predict the temperature tomorrow, where x is the number of hours since midnight, and y is the temperature in degrees Celsius. Write a function that models this temperature over time, and they want us to find what the coldest temperature is. So they would essentially like us to find the y value of the vertex. So it is important that you're able to interpret what they're asking us to find. Remember, the y-axis represents the temperature, and the coldest would be the minimum, and that minimum will always occur at the vertex. So here they're essentially asking us to find the y value of the vertex. All right, so let's look at the information that we are given. For this one, you can see that we're given our x-intercepts at 4, 0 and 24, 0, and then we are given an additional point at 0, 9.6. So remember, when we have the x-intercepts and additional point, we will use that intercept form, which looks like this. So we can say x minus 4 and x minus 24 for our intercepts, but just like the last example, we still have that a value we need to work with. So we're going to need to use our additional point, which is 0, 9.6, and we're going to need to substitute that for x and y to help us solve for a. So we have 9.6 equals a times 0 minus 4 times 0 minus 24. And we should get that a equals 0.1. So now we are able to create the function, and they want us to call it f. So let's say f of x will equal 0.1 times x minus 4 times x minus 24. So that's our model. And now we need to use that to help us answer the question, which was what was the coldest temperature. So in order for us to find the y value of the vertex, first we need to find the x value of the vertex. Remember, that will always occur at exactly halfway between your two intercepts. So the x of your vertex, we could do 4 plus 24 divided by 2. So that will occur when x is 14. So we're simply going to take that x value and plug it into our model. So 14 minus 4 times 14 minus 24. So f of 14 is negative 10. So again, if they want just the coldest temperature, that will actually just be the y value of the vertex. So the coldest temperature is negative 10 degrees Celsius. That does occur 14 hours after midnight. But again, here, the actual temperature will always be that y value for this example. So again, here you can see how important it is that we are able to model this quadratic function, and then we use that model to help us answer questions about this scenario. All right, so now we're going to talk about how to write an equation for a set of data. So when you have a table of data, the first thing you need to do is to determine what type of function best fits that data. So when you're doing this, one thing you could do is if you have equally spaced x values, one thing you can start looking for is patterns within your y values. So you'll notice here that our x values are all 2 units away. So I'm going to look for patterns with my y values. So I can see from here to here, I'm adding 4. Here to here, I'm adding 4. And I notice that that pattern is consistent the whole way through. So if you are adding or subtracting the same number to get to the next x value, that's what's called a common difference. It essentially means that the rate of change of your data is consistent, or another way of saying that is that it has a constant slope. So when you have that common difference, like you see here, this is going to be a linear function. We would model this with a linear function. Okay, so that is one type of data that you might come across. But of course, today we're talking about quadratic functions. So let's look at what that would look like for a table of data. So again, you do need to make sure you have that consistent x value or difference between the x values, so that is evenly spaced. So now I'm going to look for patterns here. Now, patterns don't always have to involve addition or subtraction. They can involve multiplication or division. But let's check for some pattern here. So I see from 9 to 4, it's -5. And then from 4 to 1, we have -3. And then we have -1. And then we have +1. Then we have +3. And then we have +5. So maybe you're looking at this and saying, well, there's no common difference, which is true. But that doesn't mean we're done. We can actually check for the next layer of difference, which is called the difference of the differences, or sometimes it's called the second differences. So now let's look for the difference of the differences. From -5 to -3, we add 2. Oh, here again, we're adding 2, we're adding 2, we're adding 2, we're adding 2. So if you have a common second difference, I'll write that down, or common second differences, so that second tier of differences, that means that we can model this with a quadratic function. So if you don't have that initial common difference, don't be deterred. Always check to see if there's that common difference of differences. And if there is, then you know that we can use a quadratic function to model it. All right, so let's look at this next example. This says, NASA creates a weightless environment by flying a plane in parabolic paths. The table below shows the height, which is h of t, in feet, of a plane t seconds after starting the flight path. So this time our x-axis represents time in seconds. Let me highlight that, t seconds, and our y-axis represents the height in feet. This says after about 20.8 seconds, passengers begin to experience a weightless environment. Write and evaluate a function to approximate the height at which this occurs. So here they're asking us to find the height when t equals 20.8. But of course, for us to do that, we're going to need to create our quadratic model first. So the first thing we need to do when we have a set of data is we need to actually make sure that this can be represented with a quadratic model. So let's do our test. So first we're going to check for a common difference. Here we have 1025, 475, and then here we have -75, and our last difference is -625. So with this, we can see that it's definitely not linear. But now we know to next check for that difference of differences. So the difference here is negative 550. And we do need to make sure that it is consistent throughout our entire set of data. And all of these differences are negative 550. So we can see that this is a quadratic function, or we can model it with a quadratic function. So now we have to decide what strategy we should use. And for this, we don't have our vertex, we don't have our x-intercepts, but we do have a lot of points to pick from. So we're actually just going to pick 3 points and create a system of equations. So I'm just going to I'll pick this first point, I'll pick this point, and I'll pick this point. It is kind of arbitrary which points you choose, so you don't have to pick the same ones as me. But those are the 3 that I'm going to use. So with this first point, again, I'm going to be substituting into our standard form ax squared plus bx plus c. So I'm going to replace x with 10 and y with 26,900. So we have 26,900 equals 100a plus 10b plus c. So remember, I just substituted x with 10, and 10 squared is 100, and then there's my 10 here. But you can see, since I have 3 variables, a, b, and c, I do need 3 equations to solve the system. So then I'll use this next coordinate to make a second equation. So here we have 400a plus 20b plus c, and then I'll use this third coordinate that I picked to create my third equation. Okay, so now that I have my system of 3 equations, I need to start solving. So when you're solving a system of 3, we're going to use that elimination method. So we're essentially going to add 2 of our equations to try to eliminate one of our variables, but we're going to do that twice. So here I think the easiest thing for us to eliminate would be our c variables. So maybe I'm going to take my second equation here, so 30,600 equals 400a plus 20b plus c, and then I'll take my first equation and I'll multiply both sides by -1 and put it right underneath. And then I can see that if I add vertically, it eliminates my c variable. So that gives me 3,700 equals 300a plus 10b. But I need to do that again. So I can, maybe this time I'll do my third equation, and I need to use a different 2 sets. So I'll take my third equation, and then I'll do the same first equation, multiply both sides by -1. Minus 10b minus c. So here you can see that if I add vertically, I get 5,200 equals 800a plus 20b. So now I have a system of 2 variables here, which we know how to solve. I'm going to use elimination again. I think I'm going to I'll put that second equation on top. And then I'm going to multiply this equation by -2, so my b's will cancel out. So we get -7,400 equals -600a minus 20b. So we get -2,200 equals 200a. So we get a equals -11. And then we just start back substituting into any of our equations. So if I maybe substitute this back into this equation here, and you solve for b, you should get b equals 700. So we have our a value, we have our b value, and then we can go back and substitute into any of our original 3 equations for a and b Maybe I'll just do that first equation. So we have 26,900 equals 100 times negative 11 plus 10 times 700 plus C, and we should get that C equals 21,000. So now that we have solved for A, B, and C, we can now create our model. So we're going to call this model h of t, and I'm going to use the variable t from here on out. So our A value is negative 11, so negative 11 t squared plus 700 t plus 21,000. So that's our model. And then now that we have our model, we can finally answer that question that was posed at the very beginning, essentially to find the height when that passengers experience that weightlessness, which is 20.8 seconds. So we're just going to evaluate our function at 20.8. So we could just plug this into our calculator, and we should get 30,800.96 approximately. So we just want to make sure to include the correct units here. We know that our height is in feet. So we have 30,800.96 feet is when the passengers experience that weightless environment. So you can see that when you have to work with this system of equations and create the three equations from standard form, it's definitely going to be the most work intensive, but really, it's just solving our systems, which we learned about last unit. So it should be pretty doable for us. And then again, once we have our model, we can use that model to answer any supplementary questions. All right, so now that we know 3 different ways to create a quadratic model by hand, now we're going to try actually using our graphing calculators to help us complete what's called a quadratic regression to model data that closely fits a quadratic function. So now we're not going to be working with data that's necessarily a perfect quadratic function, but as long as you're close to a common difference of differences, we can use this quadratic regression to create a model because it's a pretty close fit, and it can be used to help us make predictions. So here I have some steps shown out for a TI-84 Plus. I'm going to do my best to show pictures of what my graphing calculator looks like along the way, but please refer back to these steps as we go on and as you're trying it with your own calculator. All right, so here we have a table below that shows fuel efficiencies at different speeds. And then we want to create a model that best fits this data and then use that to approximate the best gas mileage. So if they want the best gas mileage, they're essentially asking us to find the Y value of the vertex. But first, before we do that, we need to create our model. So here you'll notice that our x values are not evenly spaced. So we actually can't even check for that common difference of differences. But what we can do is we can make a scatter plot of our data and then use that to look and see if it looks like it could fit a quadratic model. All right, so this is a little bit low tech, but I have some different images of my graphing calculators. That first step that was on the last page is we actually need to turn on our plot function. So if you go to y equals and you highlight plot 1, you're good to go. Then we need to enter our data. So you hit this stat button, and then you hit that first option, which is 1 for edit. And then you could enter your data in L1 and L2. So L1 should be all of your x values, and L2 should be all your y values. And just make sure you do this carefully. Make sure the x and y values go with their corresponding part. And then before we graph, I recommend setting your window first. So you hit this window button, which is right here. And then I just use my table of values to see what my highest x value is. So I just went a little over. My highest x value is 70, so I just went up to 80. I scaled it by 10, but you can scale it however you like. And then here I just went from 0 to 30 to encompass all of my y values, and I scaled that by 5. So just use your table to make sure you your max and your min cover all of your values. I usually like to set my min to 0 for these types of problems, but you don't have to. And then from there, you just hit y equals to graph, and then you see your scatter plot. So with this, we can see that this does make that parabolic shape. So that tells us that we can model this with a quadratic function. So that's how we will be checking for this if we don't have that equal spacing with our x values. Now, alternatively, if you don't have a graphing calculator, the way you would determine this is by actually physically plotting the points. So on your x, y axis, you can take a moment and just estimate where these points would be. So in doing so, you can kind of see, okay, we do have that parabolic shape, so we'll model this with a quadratic function. So now that we know that we're going to do a quadratic regression, we're actually going to run through that. So let me add in my next round of pictures. All right, so we're going to need to run that regression model. So you hit stat and you scroll to the right to calculate, and then the fifth option, you could just hit the 5 or scroll down and hit enter is the quadratic regression. So a couple things to make sure of here. Where it says X list, for us, we want it to say L1, or it should be wherever you entered your X values, which we can just keep in L1. And then for Y list, you want to make sure it's your appropriate Y values, which we did enter in L2. This one right here, this is an optional step. In those set of directions, I showed you how you can actually save the equation into your graphing calculator for under y equals. So I have it saved to go under y1. Again, this is totally optional, but it's kind of a nice thing to do. And then you take your cursor and you scroll down until calculate is highlighted, and then you hit enter. And then what you'll see is that it runs this quadratic regression. So it's telling you here's the form. You can see it's that standard form, ax squared plus bx plus c, and it tells you the a, b, and c values. So at this point, I would write down what the a, b, and c values are. Maybe we'll just round to the nearest thousands for all of them, because you're going to use that for as your model. So we could just say that we could say y equals, if your a value is that, we can say negative 0.014 x squared plus, and then we look at our b value, let's round it in the same way, 1.366 x, and then our c value is negative, so minus 7.144. And then how you round it is up to you or up to the directions, but this writing down those a, b, and c values and plugging them in here gives you the model for our function that models our data. Now, it is nice to graph that to see if it does in fact fit your data, just to kind of take a look at it. So here you can see that I have the saved version. So you'll see it has much more, it has way more decimal points because again, it kind of automatically saved it. Or you can just type in this function that you created. And then if you hit graph, you'll see that that model is a really good fit for all of our points. And again, you can see it doesn't go through all of the points exactly, but with a regression model, it doesn't need to be a perfect fit. It's more of a, the line of best fit. So you can see that this one is a pretty good fit. So you could tell that this would be a good model for us. Now, if you look back at the original question, they want us to use this model to approximate the best gas mileage. So from here, we actually are now looking for the y value of the vertex. So you could do this using this equation. You could do it by hand, but we have our graphing calculator, so let's use our graphing calculator to help us do this. I'm going to add in a couple more pictures really quick. All right, so finding a maximum or minimum value in your calculator is going to be really, really useful. You'll probably do it a lot over the course of your high school math career. So to get to this function, we want to get to calculate. You hit second trace, because if you see right above trace, it has that word calc. We want to get there. So you hit second trace, and that leads you to this screen. Now here we want to select option 4, so you can either scroll down or just hit 4. And then your graphing calculator is going to ask you a couple things. First, it's going to say left guess. So you're going to have your little cursor, and it wants you just to be anywhere to the left of the maximum. So you don't even need to be that close. You'll bring your cursor somewhere around here, and you'll hit enter. And then it asks you to take a guess to the right. So you'll scroll your cursor over somewhere to the right of the maximum. Doesn't need to be super close, maybe around here. And you'll hit enter again. And then it will ask you to guess again. So you'll hit enter a third time and it will estimate this value. And it's going to be pretty exact, but we technically would call it an estimate. So again, you have to get to the left of the top, hit enter, scroll to the right, hit enter, and then you hit enter a third time, and it will give you the X and Y value of your maximum. So from here, remember they wanted the Y value of the vertex, which was that gas mileage, miles per gallon. So our answer would be 26, let's just say 26.2. So the maximum miles per gallon would be 26.2 miles per gallon. Now, depending on how you rounded your A, B, and C values, that maximum X and Y values, they might be slightly different. So like maybe by a tenth or 100th or even 1,000th, but that would all just be due to rounding. So as long as your answer is really close to this, you should be fine. All right, so now I have one for you to try on your own. So let's see if you can follow that process again without looking at your notes as much as possible. And please note there are directions on how to clear your table of values, so make sure you follow those directions closely. All right, go ahead and check your work here. So again, you can see that this does kind of follow that quadratic type shape, or hopefully you did the scatter plot on your graphing calculator as well. If you run your regression model, check your A, B, and C values, and then here, again, they want us to approximate the best gas mileage, which would be, again, the Y value of the vertex, which was approximately 29.4 miles per gallon. All right, that's all for today's video. Thank you so much for watching.